Hello, let's solve practice set 2.2. Question first. In triangle PQR, point S is the midpoint of side QR. If PQ equals 11, PR equals 17, PS equals 13, find QR. Question first. Solution. Statement is about triangle PQR. It tells us that in a triangle PQR, S is the midpoint of QR. Okay, S is the midpoint of QR, and therefore sec PS will be the median. PQ equals 11, PR equals 17, and PS equals 13. Then find QR. Okay, here you may note, as seg PS is a median, we can apply Apollonius theorem, and according to Apollonius theorem, PQ square plus PR square equals 2PS square plus 2QS square. Using this formula, we are going to get value of QS, but QS is half of QR since S is midpoint of QR, and then we can find length of QR. Let's say here in a triangle PQR, S is midpoint of QR, and therefore seg PS is a median, and therefore PQ square plus PR square equals 2PS square plus 2QS square by Apollonius theorem. And therefore 11 square plus 17 square equals 2 into 13 square plus 2QS square. Okay, 11 square plus 17 square equals 2 into 13 square plus 2QS square. And therefore square of 11 is 121, square of 17 289 equals 2 into square of 13 169 plus 2QS square. Now addition of 121 and 289, 1 plus 9 gives us 10, carries 1, 8 and 1 9, 9 and 2 11, again carries 1, 1 and 2 3, 3 and 1 4, 4 1 0 equals 2 9s are 18, carries 1, 2 6s are 12, and 1 13, again carries 1, 2 1s are 2 and 1 3 plus 2 QS square, and therefore 2 QS square equals 410 minus 338, and therefore 2 QS square equals 10 minus 8 gives us 2, then 10 minus 3 gives us 7, and 3 minus 3 gives us 0, and therefore QS square equals 72 upon 2. 2 1s are 2, 2 3s are 6, 2 6s are 12, and therefore QS square equals 36, and therefore QS equals 6. Now QS is half of QR, and therefore QR equals twice of QS, that equals 2 into 6, and therefore QR equals 12. Question second. In triangle ABC, AB equals 10, AC equals 7, BC equals 9. Then find the length of the median drawn from point C to side AB. Question second. Solution. In triangle ABC, we are interested to find length of median on side AB through point C. That's why let's consider C be the upper vertex. ABC is this triangle. In this triangle, M is a midpoint of AB, and therefore seg AM will be the median. AB equals 10. AB equals 10. BC equals 9. AC equals 7. BC equals 9. Then find the length of median. Okay, it is easy to find length of median from point C on side AB. Let in a triangle ABC, seg CM is a median on side AB, and therefore CA square plus CB square, CA square plus CB square equals 2CM square plus 2AM square by Apollonius theorem. And therefore CA, length of CA is 7. CA square means 7 square plus CB square means 9 square equals 2 into CM square. We don't know what is the length of CM, plus 2 into AM square. AM is half of AB, means AB by 2 its square. Since AM equals half of AB. Now square of 7 is 49, square of 9 is 81 equals 2CM square plus 2 into length of AB is 10, 10 upon 2 its square. 2 ones are 2, 2 5s are 10. And therefore 9 plus 1, 10 carries 1. 8 and 1, 9. 9 and 4, 13. 130 equals 2CM square plus 2 into square of 5 is 25. And therefore 130 equals 2CM square plus 25 into 2, that is 50. And therefore 2CM square equals 130 minus 50. 0 minus 0, 0. 13 minus 5. Yes, 13 minus 5 gives us 8. 2CM square equals 8. And therefore CM square equals 80 upon 2. 2 ones are 2, 2 fours are 8, 2 0 0. And therefore CM square equals 40 equals 4 into 10. And therefore CM equals 2 root 10. That is length of median from point C on side AB is 2 root 10. Question third. In figure, sec PS is the median of triangle PQR and PT perpendicular QR. Prove that PR square equals PS square plus QR into ST plus QR upon 2 bracket square. PQ square equals PS square minus QR into ST plus QR upon 2 its square. Question third, solution. Okay, we are interested to prove that PR square equals PS square plus QR into ST plus QR upon 2 its square. and PQ square equals PS square minus QR into ST plus QR upon 2 its square. If you observe a diagram carefully, you may note due to median PS, sec PS is a median, okay, and due to that seg PS, triangle PQR is divided into triangles, triangle PSQ and triangle PSR, okay. In triangle PSQ, you may note angle PSQ is acute angle, and in triangle PSR, angle PSR is obtuse angle. And yes, we learned applications of Pythagoras theorem in a case of acute angle triangle and in a case of obtuse angle triangle. And we used to give equation for a side opposite to acute angle in a case of acute angle triangle, and an equation for a side opposite to obtuse angle in obtuse angled triangle. Okay. Here we are interested with PR square. PR is a side opposite to obtuse angle. That's why in a proof, let's start here from figure. In a triangle PSR, angle PSR is greater than 90 degree. PT perpendicular line SR such that T dash S dash R, T dash S dash R, and therefore we have an equation for PR square. PR square equals PS square plus SR square, PS square plus SR square plus twice of SR into ST, SR into ST, okay, by application of Pythagoras theorem in obtuse angled triangle, okay, and therefore PR square equals PS square plus SR, SR is half of QR or QR upon 2, we can write QR upon 2 its square plus 2 into SR is half of QR means QR upon 2, QR upon 2 into ST, that is since QS equals RS, QS equals RS equals half of QR, half of QR means QR upon 2, and now here 2 ones are 2, 2 ones are 2 will get cancelled, and therefore PR square equals PS square plus QR upon 2 its square plus QR into ST, QR into ST, and on rearranging terms on right side we get therefore PR square equals PS square plus QR into ST plus QR upon 2 its square. Let's call equation first. We have proved first equation PR square equals PS square plus QR into ST plus QR upon 2 its square. Similarly, in a triangle PSQ, angle PSQ is less than 90 degree. Okay, and angle PSQ is less than 90 degree. Seg PT is perpendicular to QS such that Q dash T dash yes, and therefore we may apply Pythagoras theorem. Application of Pythagoras theorem in acute angle triangle. We used to give an equation for a side which is opposite to considered acute angle. Considered acute angle is angle PSQ and side opposite to that angle is PQ. That's why PQ square equals PS square plus QS square minus twice of QS into ST dash dash by application of Pythagoras theorem in acute angled triangle. Okay. Now again QS is a part of QR, which is QS is half of QR. That's why we can write therefore PQ square equals PS square plus QS we can write as QR upon 2. Okay, QS square means QR upon 2 its square minus 2 into QR upon 2 into ST dash dash dash. Since QS equals RS equals half of QR, and half of QR means QR upon 2. 2 ones are 2, 2 ones are 2, 2 will get cancelled, and therefore PQ square equals PS square plus QR upon 2 its square minus QR into ST, and therefore PQ square equals, let's rearrange right side to get right side like to prove PQ square equals PS square minus QR into ST plus QR upon 2 its square. Equation second, hence the proof. Question fourth. In triangle ABC, point M is the midpoint of side BC. If AB square plus AC square equals 290 cm square, AM equals 8 cm, find BC. Question fourth. Solution. He talks about triangle ABC, in which he tells us M is a midpoint of side BC, therefore seg AM is a median. He tells us AB square plus AC square equals 290 cm square and AM equals 8 cm. Asking about side BC. Okay. From the nature of diagram, you may identify that as here is median AM, we can apply Apollonius theorem. In a triangle ABC, M is midpoint of side BC, and therefore seg AM is a median, and therefore AB square plus AC square equals 2AM square plus 2BM square by Apollonius theorem. And therefore already he gave AB square plus AC square as 290 cm square. 290 equals 2 into 8 square plus 2 bm square, and therefore 290 equals 2 into 64 plus 2 bm square, and therefore 2 bm square equals 290 minus 2 4s are 8, 2 6s are 12, 128, and therefore 2 bm square equals 10 minus 8 gives us 2, 8 minus 2 gives us 6, and 2 minus 1 gives us 1, and therefore bm square equals 162 upon 2, 2 1s are 2, 2 8s are 16, 2 1s are 2. Therefore bm square equals 81, and therefore bm equals 9 cm. Now bm equals cm equals half of bc, and therefore bc equals twice of bm equals 2 into 9, and therefore bc equals 18 centimeter.